Okay, let's get right into this. Welcome to The Explainer. I'm your host, your strategist, and today we are strapping in for an absolute masterclass. Have you ever seen the movie John Wick? He is the boogeyman, right? And what is his entire philosophy? When he gets pushed out of his comfort zone, he pushes back. Hard. Well, today that is exactly what we are doing with the Cambridge Mathematics exam. The examiners are going to push you, they're going to try and trick you, and we are going to push back with absolutely perfect, unshakable answers. Whether you are building your foundation in syllabus codes 0580 or 0606, maybe you are testing the waters in 4024, 4037, or 4040. It doesn't matter, because we're using all of that to dominate one of the most notoriously brutal sections of the Cambridge AS and A-level Mathematics 9709 exam. I am talking about kinematics. Specifically, we are hacking the SUVAT equations for constant acceleration. That is, displacement, initial velocity, final velocity, acceleration, and time. If you are tired of guessing, if you are tired of losing silly marks, and you want to start engineering perfect scores, you are in exactly the right place. Let's do this.
I want you to look closely at this number on the screen. 15. I'm putting this up first to immediately grab your attention, because SUVAT equations for constant acceleration account for a massive 15% of the total marks in Paper 2 of your mathematics exam. 15%, that is not just a drop in the bucket. That is a massive, grade-defining chunk of your overall score determined by just one specific subtopic. Think about it. That is the difference between a B and an A, or an A and an A star. This isn't just a minor hurdle you can afford to skip over during your revision. This is a major battleground. This is where the top grades are quite literally won or lost. If you can lock down this 15%, you are giving yourself a massive buffer for the rest of the paper.
But the stakes are incredibly high, and so many students mess this up. Look at this direct quote straight from the principal examiner report. The classic mistake is providing generic answers not specific to the question context. To show you exactly what this looks like in the real world, I want to introduce you to two past students of mine. Let's call them Alex and Sam. Now, Alex is incredibly smart, but Alex overloads every answer with raw mathematics facts. Alex just vomits every formula onto the page without any real analysis of what the question is asking. Then we have Sam. Sam is always rushing. Sam sees a question, panics about the time, and completely misses the specific command word requirements. When we look at their past papers side by side, it is a bloodbath of red pen marks. The examiners are practically begging students to stop bleeding easy marks. Alex and Sam do the math right, technically, but they completely ignore the reality of this scenario. They just write floating numbers on a page instead of answering the actual physical question being asked. We are going to fix that today.
So, to ensure you don't fall into the same traps as Alex and Sam, here is our tactical game plan. We have 5 clear steps. First, the 15% challenge. Second, SUVAT theoretical foundations. Third, the method mark strategy. Fourth, top 3 examiner warnings. And finally, evaluate and synthesize.
Let's move straight into Section 1, the 15% challenge. We need to figure out exactly why this specific 15% chunk of the exam is so notoriously difficult for students who are otherwise amazing at math.
Here is the secret that most teachers won't tell you. The core challenge here isn't actually the mathematics itself. I mean, the SUVAT formulas are relatively straightforward algebra once you know them. No, the biggest hurdle is the cognitive load of interpreting complex texts and data in kinematics problems. It is entirely about translation. You are reading a dense, confusing paragraph about a train braking before a station, or a particle moving along an x-axis with a variable resistance. Your brain has to extract exactly which number is your initial velocity, which one is your displacement, and which direction is positive. It is a massive cognitive load. If your extraction is wrong, your math is wrong, period.
To overcome that extraction problem, we need to move to Section 2, SUVAT theoretical foundations. We need to look under the hood and understand what the Cambridge examiners are actually trying to assess behind the scenes.
You have to realize that every question is targeting specific cognitive domains. They are measuring your knowledge and understanding, your application, and your analysis. What this means is that if you just memorize the formulas, you will fail the analysis part. You have to decode the command words. If a question says, "show that," it means the examiner already gave you the answer, and they are purely grading your step-by-step logic. If the command word is evaluate, they don't just want a number, they want you to weigh the significance of that number. Success requires conceptual mastery. You have to know the rules of the game to win the game.
And to win the game, we use a specific framework. Top students structure their mathematics answers using what we call the PEAL framework. You might know PEAL from English class, right? Point, evidence, explanation, link. Well, it works miracles in Cambridge mathematics too. Your point is stating the correct SUVAT principle or equation. Your evidence is extracting the exact data from the text. Your explanation is your clear, step-by-step algebraic working. And your link is connecting that final numerical answer back to the real-world context with the correct units. This framework explicitly forces you to hit precise definitions, causal relationships, and cross-topic connections. The principal examiner reports explicitly state that candidates who do this achieve significantly higher marks. Now, I am going to show you an interactive challenge on screen in a second, and you have 30 seconds to spot which answer actually follows the Peel framework. But before we continue to that interactive challenge, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, moving on.
Now we get to the really actionable part. Let's look at Section 3, the method mark strategy. This is the exact tactic that transforms rote memorizers into highly strategic, top-tier problem solvers.
Let's bring back our students, Alex and Sam. We sat them down and explained the Peel framework and the method mark strategy. I cannot emphasize this enough, guys. Examiners award significant marks for your process, not just your final numerical answer. In Cambridge mathematics, showing clear working and systematic processing is absolutely vital. We had Alex and Sam rewrite their past paper answers live. Instead of Alex just dumping facts, Alex stated the equation clearly, substituted the numbers on a new line, and solved step by step. Instead of Sam rushing the command word, Sam explicitly wrote down evaluating the displacement before doing the math. It was incredible. We watched the red pen marks literally transform into green check marks. If you make a tiny arithmetic error right at the end, maybe you drop a negative sign, but your method is flawless, you still secure the vast majority of the marks.
This is what we call the mathematics success blueprint. Top students systematically follow this exact chronological sequence every single time. First, identify the key elements from the text. What is U? What is V? What is T? Second, apply the relevant principles. Choose your SUVAT equation strategically based on what is missing. Third, execute the analysis with incredibly clear working. One step per line. Fourth, verify your results. Does this number make logical sense? And fifth, present the information in the appropriate format using strict conventions and units. This is how you lock in every single method mark available. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
And this table brilliantly illustrates what step 1 of that blueprint actually looks like in practice. Before top students even touch their calculator, they use their data interpretation skills. They scan the complex text and tables to extract and organize initial and final velocity. They interpret the spatial relationships to nail down displacement and time. And they draw evidence-based conclusions from the given context to define their acceleration. For example, if the text says an object is dropped, your critical action is instantly knowing initial velocity is 0 and acceleration is gravity. You don't wait to figure that out halfway through the problem.
But even with a great method, things can go horribly wrong under pressure. That brings us to Section 4, Top 3 Examiner Warnings. We are going to do a quick interactive workshop to see the exact traps you need to avoid.
All right, it is workshop time. I am putting 60 seconds on the clock for Challenge 1, the data scan. Look at the complex kinematics data on your screen. You have 60 seconds to extract the core trend. Go! Are you scanning for the peak velocity? Are you checking the axes to see if time is in seconds or minutes? 30 seconds left. If you don't convert minutes to seconds, you fall right into mistake number 1, forgetting proper format. Time is up. Now for Challenge 2, find the flaw. I'm putting a sample paragraph up. Take a look. Where's the student losing marks? Let me give you the examiner commentary. The student wrote V equals 0 without defining what V means in this context. They failed to check presentation and terminology. That is mistake number 2. And mistake number 3, as always, is providing generic answers not specific to the context.
You can clearly see the difference between these two approaches. The flawed approach treats the question like a textbook exercise in a vacuum. It is just generic, non-contextual equations. But the top-scoring approach ensures that every single point and metric is explicitly linked back to the original scenario. Now, for Challenge 3, speed writing. I'm putting a 30-second timer on the clock. I want you to write one perfect PEL paragraph explaining why a car's acceleration is negative in a braking scenario. Go! Point. State the definition of deceleration.
Evidence: pull the final velocity of 0 from the text. Explanation: show that final minus initial velocity over time yields a negative value. Link: state that the negative sign indicates the force is opposing the direction of motion. Time is up. If you can do that in 30 seconds, you are golden.
Now, to help you remember all of these variables under massive exam pressure, here's a fantastic memory hack straight from our source material. Take the key kinematics terms and use the mnemonic SUVAT. Itself is a mnemonic. S for displacement, U for initial velocity, V for final velocity, A for acceleration, and T for time. When you sit down in that exam hall and the panic sets in, write SUVAT vertically on your scrap paper. Immediately fill in the numbers you know from the text. It anchors your brain. It stops you from freezing when the clock is aggressively ticking down.
Let's enter the final phase of our methodology in Section 5, Evaluate and Synthesize. This is where we completely separate the passing grades from the absolute top-tier candidates by focusing on how they review their own work.
Top problem solvers use this complete system, the deconstruct, solve, evaluate blueprint. To master this, you need the 3 rules that guarantee top marks. Rule 1, command word decoding. Never start mathing until you know exactly what the verb is asking. Rule 2, peel framework application. Structure your math logically so the examiner can follow your brain. Rule 3, the time management matrix. Allocate your time strictly based on the mark scheme. If a question is worth 2 marks, do not spend 10 minutes writing a novel. Deconstruct, solve, and most importantly, evaluate. Check for reasonableness.
Achieving those absolute highest grade boundaries requires active evaluative thinking. This means identifying limitations in the mathematical models. It means recognizing assumptions you have made. Did you assume air resistance is negligible? Did you assume the string is light and inextensible? You must consider these perspectives and always justify your mathematical decisions with hard evidence from your working. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
So, I want to leave you with this final, provocative thought to chew on. Next time you are doing a past paper, late at night, grinding through the questions, ask yourself honestly, when you finish a SUVAT calculation, are you just blindly rushing to the next question to save time, or are you actively checking your final answer for reasonableness against the original context? If you calculate the speed of a running human and get 800 meters per second, do you stop and realize something has gone horribly wrong? Mastering that single habit of evaluation might just be the ultimate key to securing that final 15%. Thanks for joining me on The Explainer, and keep pushing back on those past papers.